Alright, good to go there. Okay, we did, I think, 2 or 3 examples of each of these yesterday. Had 1 or 2 in your assignment. So hopefully this is about that middle of the road that we aim for. Alright, that kid's gone. Here, here, here. Okay. Someone had asked yesterday, and yes, your next quiz will be on Friday, just because how everything is spread out here. Monday quiz, 4-day weekend, food day, all got kind of mucked up. Sophomores, remember on Tuesday, you will be in here first hour, and then go do your pre-ACT. Don't stress about it. Usually you get the kids in pre-calc are the, I've always been perfect. I've always been smart. I have straight A's. I have to get a perfect score. Oh God, I got a 28. I'm gonna, and they hyperventilate and freak out. Just go into it, try your best, but don't stress about it. It's an indicator. It's a litmus test. Okay. But y'all will be blocks 2 through 4 on Tuesday. We'll be doing that. If anyone misses that day, there is no makeup scheduled day. You just missed it. NWEA and state testing for freshmen and juniors respectively, those we do have makeup days for because we're required to by state. But pre-ACT is just something the school pays for to give students and families kind of an idea of where they're headed academically. So there's no makeup day for that. It's just something we do. Get good data out of it.
Is that the same schedule? Like we'll have lunch at the same time and everything?
Yeah, it's Maroon Day. Well, I take that back. Because the sections are timed, your lunch might be a little bit different. And that's okay. They always work that in. They make sure that the lines are open for those kids at those times. If you decide to leave during that time, still you can leave. But I think it is a little bit different because each section is a little different, where maybe it's 60 minutes for the math portion, 45 minutes for the English composition portion, 30 minutes for the English reading portion. Like, they're all a little bit different, get kind of wonky, a little bit of a break in between. So you might not have the exact same lunch, but around then. I know I talked to a couple who did the regular ACT this past weekend, and I mean, they run a tight ship. It's, you have this much time, pencils down, don't you dare touch anything else or we throw your test out. You have exactly 7 minutes in between these two sections to run to the bathroom and back. Like, they're pretty, but that's the ACT, because that determines scholarships. It determines college entrance. And I've seen entire, like, rom-com movies about someone who cheats their way through the SAT. Like, it's that big of a deal. So pre-ACT though, that's just get the jitters out of the way, so you know what it feels like. Inverses. I think most of us were pretty well just jumping straight to this. Because you're going to replace f of x with y, and then you're going to swap x and y. So most of us are jumping straight there. By now, we have learned the trick. Cross multiply, got 2xy minus x is y. All your y stuff on one side, your not y stuff on the other side. So 2xy subtracted over minus y added over equals x. Factor out y. And finally, write it as an inverse function format. Say the inverse function of x is x over 2x minus 1. Whether you're looking at the restriction to the domain here or the restriction to the range up here, in either case, x cannot be 1/2. If you wrote it as full domain mode, negative infinity to 1/2, 1/2 to infinity, that's fine. But it does say, oh, it does say domain, full domain. If you wrote the restriction, that's fine. Okay, restriction or whole domain, I'll take both. That was my fault.
Negative x over negative 2x plus 4.
Same thing. Because remember, if I take this times a -1 over a -1, it just changes all the signs. So you got the right one. You're good. Okay, round 2. Same deal. I will turn this into a y, swap x and y. X is 2 root of y minus 1. You have choices. We're going to review radicals here moving into chapter 2. I can either divide by 2 and then square it, which means I got a fraction, or I can square it right now, remembering to square outside the radical and the radical. But then I'll have to either distribute or divide. Both are fine. Okay, so what I'm saying is either I could divide by 2, square, add 1. Words. Or I could square like that. Square the outside, square the inside. But then either I distribute, but then I'll have to divide that 4 in front of the y later anyhow, or I can divide right now. Okay? So either way, you get to the same place. So I'll have inverse g of x is either x squared over 4 plus 1, or you may have had x squared plus 4 over 4 altogether, or 1/4 x squared plus 1. Like, they're all the same thing. So any of those is cool. And my restriction, normally I would think, well, that's a parabola, all real numbers. But I got to remember that the original had a domain of 1 to infinity, range of 0 to infinity. So that means, domain and range swapped, this guy has a restriction of 0 to infinity. Okay, we ran across a couple of those. So we'll kind of do 2 each and a floater. Did you get the function? Did you get the domain? Did you get the function? Did you get the domain? And 1 floating for, oops, I squared like a freshman. I missed a negative. I factored incorrectly. Okay, whatever it be. Anything about it?
Wait, how's the range on the first one? Rated at 0.
If I plug a 1 in, 1 minus 1 is 0, square root of 0 is 0, 0 times 2 is still 0. Okay. All right. Womp, womp, womp. Then this goes away. Poke. We got all kinds of stuff. There. Talk to me, Goose. How'd we do with that 40-something? I picked, I thought, the easiest one of the bunch. Wasn't it a 40-something?
43? Yeah, I think it's for 1.6.
Oh, 1.6 was the composition guy. Okay. Okay, compositions get funky. So when I decompose, you got a bunch of different ways you can roll with it. PreCalc, student, 1.6. There we go. Boy, I'm like 5 different PDFs open. There we go. So the way that they do it in our solutions is actually about how I would do it as well. Actually, no, they didn't. What I would have done is leave f of x this whole nastiness. Okay, I'd start there. All of that is nasty, so leave that for f of x. Then, what I'm plugging in, well, if I put a x minus 1 in here, check. But if I put a x minus 1 in here, well, now it'll be a x minus 1 instead of an x. So I need to alter f of x just a little bit so that that minus 1 won't be there. Nice and simple. I put that there. And now g of x will just be x minus 1. X minus 1 goes here, check. X minus 1 goes here, minus 1 plus 1 cancels, check. Okay? That's one way to do it. Anyone get real crazy with it? Have like squares and square roots all over the place? Did we actually do it? Seeing a lot of like standby screen. Okay. Now I will show you the thing. Don't do this on your quiz. Find two functions that compose to make this. Work smarter, not harder. There was a kid who found that about 4 or 5 years ago, and does this work? I mean, it's technically not the identity. Yeah. Yeah. Minus 1. Plus 1. Ta-da! Yes, you can do that. Just don't. It's a cop-out, okay? If I throw a big nastiness at you like that, okay, cop-out. But if it's something smaller, like just 5 over x minus 1, okay, do it for real. It's not that hard, okay? But yes, that is a thing. Okay, what about from the 1/7 part? It's all feeling good? For those of us who are doing it? Okay. All right, finish 1/7, move into 2/1. Everyone got the stack of packets? Y'all got a chapter 2 packet ready to roll after this? They're back there. Yeah, we're finishing 7, moving into 2.
Oh, I thought you said we did.
No. We're going to do the last 2 things. They're pretty straightforward. Just like yesterday. Like, we are exactly 2 examples off of last semester's pace. So we're like right there. Go. So we finished off 3, 4. I already talked about. We talked about this with the definition. If I want to find an inverse algebraically, I swap x and y because I'm swapping domain and range. So that's also how I'm going to find the inverse graphically. I'm going to find points on this and swap x and y. That's it. So if I had a point that was at 1, 2, if I had a point that was about 1.5, what's that? 1, 2, 3, 4, 5. If I had a point that was at 0, 1, if I had a point that was at negative 1, 0, a point that was at, what's 1, 2, 1, 2, 3, 4, 5. So a boot, negative 1.9, negative 5. I go find points that are on there, and all I do is flip my x and y. It's not 0, 1, it's 1, 0. It's not negative 1, 0, it's 0, negative 1. It's not 1, 2, it's 2, 1. It's not 1.5-ish, 5, it's 5, 1.5-ish. It's not negative 1.9-ish, negative 5. It's negative 5, negative 1.9-ish. And you connect the dots. And it looks like a squid. You'll see him? It's a squid. Okay. We've talked about before, it's this reflection down the line y equals x. If you remember from geometry, that was your coordinate rules for reflecting across the line y equals x, was to swap x and y. We used to call this, when I taught geometry, we'd call it the Bart Simpson method. Down 1 over half, down 1 over 1. So, down 1 over 1, down 1 over half. That makes top of Bart's head. Okay? You count just the boxes, and that's how you reflect over that line. Well, now we know it's just swap x and y. Sometimes you have to ballpark it. Like I said, about negative 1.9-ish. Okay, still good enough. I still got my graph. So each of these, one's linear, one is not. Reflect them. Find the inverse graph without even knowing the function. Y'all talk to each other. You're freaking me out. Stop whispering. Talk louder. When it's quiet like this, I feel the need to fill awkward silence. Do the thing. Check with your neighbor. Okay, should be pretty quick. If it's at 0, 3, it's now at 3, 0. If it was negative 1, 1, now it's 1, negative 1. It was negative 2, negative 1, now it's negative 1, negative 2. If it was at 1, 2, 3, 4, 5, now it's 5, 1. What happens with -3, -3? Okay. And then -4, -5 is now -5, -4. This, we ran across it when we did our absolute value stuff. -3, -3, it's on the line of reflection. What does your face look like when it's pressed against a mirror? It's right there. That is its reflection. Okay. Round 2. What function is this? It's just square root, right? The square root of 9 is 3. So 3, 9. The square root of 25 is 5. So 5, 25. The square root of 49 is 7. So 7, 49. The square root of 64 is 8. So 8, 64. Okay? Does the same thing.
How many points do we need? Or does it just as long as we have the shape?
As long as you got a couple and as long as you got the shape. I would want to see some points. Oh, 2. Because otherwise you're just BSing it, right? At least make it look like you did it. So compositions that are inverses, we were okay with that. Phi, f of inverse f should come out as x. Okay. And then the graph thing we were pretty good with. This idea that the graph has an inverse swapping x and y also works in context of word problems where I want to swap my input and my output. Say I have a formula in which I input time, I get out money. Well, what if you just know what your paycheck was and you're trying to figure out how long you worked last month? Okay. Can I do the inverse? Can I flop it around? The answer is it doesn't matter. I'm a teacher, it's salary. Whether it's 40 hours like contract says or 70 like usual, you get what you get. Okay. Kendra earns $8 an hour. Quit. Go on strike. Works at least 40 hours a week. This book was also published like 15 years ago. So, receives overtime pay at 1.5 times regular hourly rate. That's federal standard for any time over 40 hours. Her earnings for the week by this function. I want to analyze that function real quick. Why do I have 320 plus?
That's like 40 times 8.
It says she works at least 40 hours. So 40 by 8. That's a constant. I'm always going to have that much. Where does this come from? Okay. Overtime, right? How many hours over your overtime? If I work 45 hours this week, I'll throw in 45 for X. It'll tell me 5 overtime hours at 1.5 times my $8 an hour. Okay, so that's just where it came from. Explain, oh, and they even graphed it for us. Explain why the inverse exists.
So she can find out how many hours she's working.
That's why I would find the inverse. Why do I know the inverse exists? This is a function that passes a vertical line test. Its inverse, I know, will also be a function because it passes a horizontal line test. Okay, that's pretty much going to be your answer every time. Then find its inverse. So We'll start with that. I will swap x and y. We'll say x is 320 plus, okay, if I just distribute and combine like terms, this is so, like, it's all spread out. I don't like that. So this is 320 minus 480, so negative 160, 12x minus 160, right? Yeah, pretty sure. So I swap my x and y. Add 160. Divide by 12, write it in my correct notation. Inverse function of x is, I could either leave it as x plus 160 over 12, or I could turn that into 1/12 x plus divided by 4, 3, 2, 2, 6, 80, 4, 3, and 40, 40 thirds. Yeah, that's as good as it gets. Okay, and take either one. So we know how to do the horizontal line test. We know how to find inverses. What do they mean?
Why didn't we add the 40 in the first equation?
Here?
You did. You multiplied
12 by negative 40 is negative 480. Negative 480 plus 320. Nope, those are good things to stop me for if I ever start muttering to myself and then just write something. So the key to this is go back to the very beginning. My x and my f of x. What did they mean? In the original equation, what was x? Hours. What was f of x? Earnings. Earnings, paycheck, wages, whatever. The whole idea behind this last example is whenever I'm finding the inverse in a word problem, since the inverse swaps domain and range, that means it also swaps their meaning. This is now earnings, and this is my hours worked. Okay? So when I swapped x and y, I also swapped their meanings, their labels. So what do inverse function of x and x represent in this? They are my hours and my earnings, respectively. What restriction should be placed on the domain for these two functions? So the domain for f of x was hours worked. What are the restrictions? What's the least amount of hours I can work? 40, not 0, because it says she works a minimum of 40. So for this one, it'll be 40 to, it's how many hours she works a week. Then you start having a labor debate, right? 24 by 7. Okay. Theoretically, if you broke laws and didn't sleep and started hallucinating, you could work 168 hours. This is where if you qualify your answer, that would be beneficial. If someone said 168 and die, All right. If someone else said, well, I actually know how this works. Do you know federal labor laws? What is the maximum amount you're allowed to work in a 24-hour period?
25 hours.
Okay. It is I want to say federal is a minimum 6-hour break between shifts for sleep. Minimum. And then every 4 hours, you are afforded a 15-minute break. Every 8 hours, you are afforded a 30-minute break for meal. Federal labor law. Okay. So say instead of 24, you can work 18 hours for 7 days. If you had instead gone with that, so what's that, 70, 56, 126? And then you said, follow the law. I would take it. So when they ask for reasonable domain and range on these, you might have to put a little scribble next to it saying why you have that number. It might not even be a number. Maybe instead of this, you wrote 40 to maximum legal limit. I would take that in a heartbeat. Okay? So sometimes that's all you can do. And then earnings. My earnings would have been, well, a minimum of 320 to whatever you said over here, plug it into your function. Okay? So the maximum legal limit of hours, let's say it was 126. Put 126 in here. Ah, crap. 14, 46, 12, 60, 72, 40, 15, 32 minus 160. Lost it. Damn. I was coming down under 1400 and then it kind of wiggled and off the road. So find the number of hours she worked last week if her earnings were 380. Which function do I put that into? Function of x or inverse function of x? I can figure it out with both of them, but which one should that be an input for? Inverse, because the inverse has a domain that is about earnings. So I'll put 380 in here. 380 plus 160, 480, 60, 540 over 12. So 540, 60, 12, 5 extra hours, 45 hours. Question mark? Okay. So, the big thing about this, A, write out what your x and y mean. Because when you find your inverse, you swap them. B, when you are finding reasonable limits to domain and range, you might have to use words instead of math. Okay, like what if it's a function and it's the number of people who attended graduation? What is the reasonable limit of domain? Well, no one could have showed up. All the way up to, I can't say infinity. I can't say 30,000. The whole auditorium or the whole gym. I would say from 0 to the capacity of the gym. Like I would have to use words instead because I don't know what the capacity is. Okay, so same thing. You got a function, go find its inverse, tell me all the stuff about it. Every year we run across this, and I read it as Soldana, not Solata, because Zoe Saldana is a very, very pretty woman.
Is she the one who plays Gamora?
Gamora, she's Nahiri in Avatar. She's Lieutenant Uhura in the new Star Trek movies. That's a pretty lady. And she's got a lockdown on sci-fi roles. No, I just distributed this first. Not yet. I did it blue. I went fraction mode so that I don't have to have nasty decimals that I round, because now my answer is accurate, and if you rounded, yours isn't. Mm. Because when you divide by 0.13, didn't that decimal keep on going? Blue, swap X and Y. Turn 0.13 into 13 hundredths. Terminating decimal, place value. Green, subtract 120. Yellow, multiply both sides by 100 over 13, the reciprocal. Okay. Again, I prefer this because this is the perfect answer. This doesn't have a round off error. When you divide by that 0.13 and then you cut part of the decimal off as you write your approximation for the inverse, whatever you just wrote, if you tried to do a composition between f of x and inverse f of x, now because you have changed it, because you have cut it off, rounded it, now you will not get x when you compose them. They have to be perfect expressions for them to actually work as inverses. Okay, if you're in my Algebra 2, you've heard that rant enough times that I am big on accuracy, and I wish that our lower classes would really harp on that a lot more. Like simplified radicals, working with expressions of trig functions in geometry. I know y'all didn't do it. Like your area for a regular pentagonal pyramid should have been something more like 33/8 sine of 55 as a final answer, and then a decimal equivalence. So, A, did the thing. Find its inverse. B, what do they represent? If the original said blah, 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 X dollars gross pay. Okay, so this is where pay and f of x was going to be savings. Then that means this one is going to have savings, input, pay, output. Okay, flop the meanings, flop the labels. What restriction should be placed on the domains? For the original, X is her gross pay. What's the least amount that her gross pay could be? It doesn't give a minimum amount that she works. It gives her expenses. So theoretically, she could have had 0 and then just gone in the hole on that week. Okay? All the way up to what? Whatever her pay is? Like, I don't know. So for a reasonable domain and range on this one, for f of x, I would have to say from 0 to f of pay. Oh, wait, brackets. That was close. 0 to f of pay. Okay, because I don't know how much she's earning. I would assume that if it's $600 a month for living expenses, her pay probably isn't a lot. Okay? $600 a month. Are you kidding me? I bet some of you have that much in expenses. How many of you are chipping in on a car payment with your parents and paying for your cell phone plan and paying your insurance, and that's why you have to work? I got kids every year that they're working just as much as their parents, but they're also doing it while going to school. Okay? 600 a month isn't going to get you too much anymore. This is very obviously an old book. For the inverse, domain is savings. What's the least amount you could save? Because she's got $600 in expenses. If I plugged a 0 in, okay, or not 0, if I had a 0 over here, then she would have been in the hole 600. All the way up to how much could she have saved? Right? Like this function, I can now put whatever I want in there. All the way up to infinity. She can be Bezos, just living in a cardboard box. Okay? I don't know. So her savings would have to be whatever savings minus 600 is. Right? I suppose technically it would be whatever you put in here. So, yeah, it gets a little dicey. And then determine gross pay for 1 month if her savings were 120. Again, they're asking savings are 120, so I'm going to use my inverse. So, the last few things from 1.7 were just application. Can you do the graph thing? Can you swap things in a word problem? Oak. 2-1. I said we're pretty close. And I figured out why. It was because last semester, one of the sections, we did a FUBAR day on a early release day. So we're actually about an hour ahead of last semester. That's why we're always about 2 examples off.
So we're ahead.
We are ahead by exactly 1 hour.
Yes.
Woo! Go us. Okay. So, a monomial. At the bare minimum, the whole lot of you are in biology, if not chemistry. Monomial. Mono means 1. Nomial.
It's like a polynomial. Yeah, one number.
Name or term. Name or term. So when I have a monomial, there is 1 term. How do I separate terms? Like, this is now 1 term. Because I threw it over 25, because I grouped it over a singular denominator. But if it was just this, now it's 2 terms. It's every time you run into a plus or a minus. And I actually do that with all the way back down to pre-algebra. Tell them every time you run into a plus or minus, chop it up. Those are your new terms. Okay? So a monomial has 1 term. And that 1 term, as I just showed you, it can be nice and simple, like 5. It could be big and gross, like big honkin' rational expression. It's still a term, but in this case, I'm talking about monomials where I don't have the denominator yet. And do y'all remember doing kind of the positive A, negative A, n is even, n is odd, where it's a x to the n? Does that look familiar? Where if I have an even power and it's positive, it's going to start at positive infinity. It's going to come do stuff, and then it's going to go up to positive infinity. We used to call this the leading term test. But when I only have a monomial, then it's not going to do any weird stuff in the middle. It's just whoop, done. But if n is even and a is negative, sad. Okay, it's just as that n increases, as it goes from squared to fourth to sixth to eighth, the vertex of it starts getting a little more thick with the C. Starts getting a little more junk in the trunk every time. Because as I go out from 0, from its vertex, it's going to go up more sharply. Okay, so instead of nicely curving out, it's going to whomp straight up. Okay, anyone ever seen air compressor automatic staples? Okay, you get a whole brick of it loaded in like a magazine, thump, thump, thump. Okay, those have that curved head to them. And that's basically what anything past x to the fourth looks like. Okay, if it's an odd, on the other hand, a positive, whoop. Again, if it's a cubic, it's like this. If it's a quintic, it's like this. If it's a heptic, it's like this. And it just stretches further and further up. Okay, I really missed that shirt. I should order another one. I had all the mathematical dances, and it's all the stick figure dudes. I kind of burnt a hole in it. So, and if it's negative, it just goes the other way. Okay. Now, if I have those, I know they'll follow that general behavior. It's just how fast they follow that behavior. Then I know what every one of my monomials will do based on the power and the sign. And that's where this first page comes in. It's that cheater chart with all the stuff written by it. The domain, the range, the intercepts, the intervals increase and decrease, the symmetry, it's all right there. Okay? So, if I know how to do analysis, I should be able to throw any function at you and you can analyze it. I don't feel the need to beat them to death. I just want you to get a wee bit of practice. Where is that? Right? It's right above on your paper, on your notes, that stuff. Show me you can do one of them. Can you graph that thing and tell me all the stuff about it? Tell me domain, range, x-intercept, y-intercept, continuity, symmetry, intervals increase, decrease. What else? And behavior. Okay.
points do we need to make?
Generally with these, we like our vertex or our point of inflection and 2 on either side, so we can start to see the curvature to it. I understand that once you start going to x to the 5th, that thing takes off pretty fast. Maybe you need to monkey with a scale to show that next point.
I just put the number and then multiplication and then divide.
Things you should just know off the top of your head. You should know perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can get your hands on. I should just know off the top of my head that 3 to the 5th is 243. 2 to the 5th is 32. 1 to the 5th is 1, 0, negative 32. Oh, negative 1. Negative 32, negative 243. What I'm graphing is a negative 2/3 of that. So a vertical reflection and a compression by 2/3. So negative cancels a third of that, 81 by 2, 161. 162, right? Okay. A third of that by negative 2, 64 thirds. Two-thirds. 0, negative 2/3. Negative 64 thirds. Negative 162. So I would say in this graph, those are probably out of line. But 64 thirds, 21 and change, I can just go by 2s and go a little bit off-road. It's fine. So at 0, plus or minus 2/3, plus or minus 21 and a third. So here's 20, 21 and a third, about there. About there. Connect the dots. And it's just really tall and skinny, odd monomial. Okay? So, once I have that, Tell me all the stuff about it. I would honestly go right above that and say D, because that's the stuff. Okay. Now, naturally, you need to know how to find all that, right? We've been doing the graph analysis for a couple weeks now. You should be able to look at that graph and tell me domain and range are all real numbers. X and Y intercepts are both 0. Symmetry is to the origin. Continuity is for continuous for all real numbers. End behavior, make sure you're writing it as limits. But because it's a monomial with those characteristics, then I know it's going to follow those characteristics as well. But when it's a negative exponent, yes, ma'am?
Why wouldn't range be going from positive infinity to negative? Why is it negative to positive?
Because you always follow number line, least to greatest. Yep. Y'all catch that? Like the domain from negative infinity to infinity, we might think that I have to follow that same left to right pattern for my range, but then that has us making a number line that goes from positive infinity to negative. So my number line would be bass-ackwards. Negative exponents, what do they do? Right? Reciprocal, flip it. So that's not 3x to the negative second. That's 3 over x squared. Well, stick a 0 in there. What happens? Thou shalt not divide by 0. You get a vertical asymptote. If I stick a 1 in there, 3. If I stick a 2 in there, 3/4. Stick a 3 in there, 1/3. And then on and on and on. It keeps getting smaller, right? Ladies' jokes and mix of all strokes. This is what a normal one looks like. I'm going to be taking that and tripling it. But then it still hits here, 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 here. This is the butt crack graph. Okay? Tell me all the stuff about it. Tell me, what is the domain, range, x-intercept, y-intercept, the symmetry, the continuity, the intervals of increase, decrease, the limit of my function as x approaches my end behavior. Tell me all the stuff about it. Domain. But not 0. So I need to exclude negative infinity to 0, can't touch this, and 0 to infinity. Range. Parenthesis or bracket. Because it never actually hits 0, 0 to infinity. X and Y intercepts. Because 0 was excluded from both domain and range. No. Symmetry. Y-axis. Continuity. It's not continuous, so tell me what type and where. Infinite discontinuity at x is 0. Intervals increase and decrease. Remember, as I go left to right across the paper, when is my pencil going up? When is it going down? When's it going up? Negative infinity to 0. As I go left to right, it's headed up. But as I go left to right, after that butt crack, it's headed down. Okay, so that'll be from 0 to infinity. Limit. As I go all the way to the left and all the way to the right, it's heading the same place. So at plus or minus infinity, my limit is, as I go all the way to the left and all the way to the right, it's getting really, really close to what number? 0. Okay. And again, you can plug that in your calculator and spam 9s. Enter. And it gives you some ridiculous scientific notation number that is very obviously close to 0. Okay, so we can analyze stuff. It's just maybe we're not as familiar with negative exponents. You. To be. I don't feel the need to do the other one. We know how to analyze. We just need a little bit of practice. So if we have no idea what this looks like, we can always throw it in a calculator, plot points, and then tell me all the stuff about it. Class mom, you're in charge. Do turn 8, 0, 5, 1/2. Okay, a boot like that. Well, it has the earmarks of a reciprocal function. So, domain. Everything except 0. Range. Everything except 0. X and Y intercepts. Nope. Symmetry.
Can it be all three?
It is not symmetric to the Y, because I would be able to take this side and put it on that side. Origin, though. Okay. Origin is rotational symmetry about the origin. You should be able to take your paper and flip it 180, and it's the same graph. Okay. And behavior. As I approach both positive and negative infinity, 0. Continuity.
A discontinuous at x equals 0?
What kind? Infinite. Okay. Infinite discontinuity at 0. Yeah. Luckily, I'm fluent in mushmouth and yawn. So. You got that friend who always they try to tell you about what they're doing after school with a mouthful of pizza or Cheetos, but you can understand them perfectly. Yeah. What else did I miss? Oh, well, as I go from left to right, we are, they're both going down. So my interval of decrease is actually the entirety of my domain. Negative infinity to 0, 0 to infinity. There's never any increase. So, do you see how you could kind of create a chart just like that first slide? You could create a chart like that for negative exponents, just whether it's odd or even, whether the coefficient in front is positive or negative. They're going to do all the same stuff. Okay? So don't worry about the other ones. I think we're good with that. And then rational exponents. Graph it. X to the 5 halves. You got no idea what x to the 5 halves looks like. But isn't that the square root of x to the 5th? So from that, before I even see it on my calculator, because it's square root of something to the 5th, what is its domain going to be? 0 to infinity, right? I can't put negatives in there, because if I put a negative 1 in, I'd be doing the square root of negative 1. So I know my domain is 0 to infinity, which means my range is 0 to infinity, which means it's continuous from 0 to infinity. So I can start to think about all that stuff based off of what I know about a function related to this one. Now, that's not always going to work, just like when a student comes into my class and I've had one of their siblings before, I can't just assume that this kid is going to do the same thing. Okay? I have one in a class right now. Both of their previous siblings had been in my room. Both of them tried to cheat their way through class. One of them is the reason we don't have retests anymore. But this kid is cool. Go figure. Okay? You can make some assumptions based off the family of functions, but they are assumptions, and sometimes assumptions can be inaccurate. So it's just, I know some stuff about it. I might want to plug it in my calculator to find the rest. So 0, 0, 1, 1. Shove a 2 in there, I get the square root of 32. So 1, 2, 3, 4, 5, almost 6. I shove a 3 in there. 3 to the 5th, 243. Square root of 243, 15 and change. So it turns out that, yeah, it still has the domain and range of 0 to infinity. It's still continuous 0 to infinity, but this thing didn't take off low to the ground the way a normal square root does. Because it had x to the 5th in there, it actually shot upwards instead. And if I had just made the assumption, I might have missed that. So, all the stuff about it. Domain, range, x-intercept, y-intercept, continuity, increase, decrease, what else? Symmetry, my limit as x approaches a thing, my limit as x approaches a thing. All right. So we said domain and range are both 0 to infinity. X and y intercepts. 0, 0. Continuous. Yes. But I can't just say continuous. Remember, we say continuous along what interval? Increasing along that interval. Decreasing? No. Symmetry? No. Limit as I approach infinity is infinity. But how do I handle the left end behavior? As I go to 0 with a plus, and it'll be approaching 0. Okay, as I approach 0 from the right. So, yeah, I might be able to say that's 6 third root of x squared. Oh, no. That's a negative 2/3. So it's 6 over cube root of x squared. I don't even remember what that does. So how do we find out? Okay. So do it on the next one over, but I'm just going to erase this. Oh, this is f of x. Okay. I don't even remember what that looks like. I mean, okay, so x is squared, so I'm going to allow positives and negatives in. And it's cube root, but it's a denominator. It's good, still going to be another one of these, right? No? Butt crack graph? Oh, yeah, because the squared. So no matter what I put in, I'll get the other one. Yep. No, I don't want key press history. I want that. There we go. So I go to y is, clear. 6x to the negative 2/3, graph of a. But now having seen that, could you pretty much copy everything from 2a? Butt crack graph gonna butt crack graph, right? Like that's just what it does. It's gonna have domain of everything but 0, range of 0 to infinity. X and y intercepts do not exist. Increasing, negative infinity to 0. Decreasing, 0 to infinity. it's going to say all that same stuff. So you could just go up to 2A right above that on the page and just copy that stuff because it's going to do all the same stuff. Okay? So we'll cut it off there because that's just the monomial stuff about analyzing the graphs. And if I remember right, after that, right? Yep, we start getting into some calculator stuff and then radicals. So we'll leave that for next time.